All right, good morning. We're going to move into the more geometry heavy part of finding arc length and sector area instead of just circumference and area. Circumference, again, is the distance around the circle. And the formula, as we talked about already, is 2 pi r, with r being the radius. Area is the amount of space inside, and the area, as we discussed, is pi r squared, with the r being the radius. In order to find the length of an arc, you have to know a couple things. The first thing is you need to know this little piece of information. This is a circle, and that's the center. There are angles that look like this, that come from the center. The vertex of the angle is on the center of a circle. This is called a central angle, and it has a really cool thing. The angle on the inside and the arc that goes with it, the opening, have the same degree. So if this was 32 degrees, then this arc is also 32 degrees. This is the measure of the arc, or the measure of the angle. This is not the length of it. Because if you think about it and you have a smaller circle, this arc also would have a degree of 32. Does that make sense? Therefore, the length is different from the degree measure, and that's what we're going to be working on here, is figuring out the length of this outside piece. How much of the circle are we actually talking about here? Okay. To find arc length, I use this proportion. There are other ways to do it, but I have found this to be the most successful with the most students. This part here, we're going to use a proportion, and this is the arc length right here. Usually this is what we're looking for. Usually. Sometimes we'll be looking for something different. We want to know the arc length over the circumference, and we're going to base that on the degree of the arc divided by the total number of degrees of a circle, which is 360 degrees around the circle. This is length, this is degrees. Okay, so kind of like similar figures where we have to keep things consistent. This is the arc, this is the whole circle. Sector area is the same exact formula with one small change. Sector area is usually x, and that's the area. So we're going to use area instead of circumference. Degree of arc over 360. And again, this whole fraction is degrees. This whole fraction is length, or area. I mean, the top is the part of the circle we're focused on. The bottom is the whole circle. So I'll do an example of each. This says we want to find the measure of arc DA, so we're looking at that piece. If the angle is 40 degrees, then the arc is 40 degrees, central angles. And the formula, that would go here, the degree of the arc. All circles are 360 degrees. And we don't know the arc length because that's what we're looking for. And on the bottom, you can see up here, we need the circumference. So we're going to actually have to calculate that. Circumference is 2 pi r. The radius of our circle is 4.5. So the circumference is 9 pi. And that is what goes down there. We're going to cross multiply. So 40 times 9 is 360 pi equals 360x. We want to get x alone, so we're going to divide by 360. So pi equals x. What that means is that this piece of the arc right here is about 3.14 centimeters long. Okay? Sector area works the same. We want to figure out how much space is shaded. This angle inside is 210 degrees, so that means the arc that we're going to work with is 210 degrees. out of the 360 degrees in a circle. We don't know the area, so that's the x, but we can find the area of the whole circle. Area equals pi r squared. The radius is 12. So the area is 144 pi. That's the area of the whole circle. Now we want to figure out the area of just the shaded part. So we have the percentage of the circle here and our full area and what we're looking for there. We're going to cross multiply. 210 times 144 is 30,240 pi. And that's equal to 360x. We want the x alone, so we're going to divide by 360. I'm going to divide 30240, 30,240 divided by 360. And that gives me 84 pi. This is the answer in terms of pi. If you would prefer to see what that means, you can multiply it by pi. And it's about 264 inches around. All right, I'm going to show you one more of each, and then I want you to try one on your own. This one's a little bit different because here's arc DA. But if you look, we weren't given the measure of that angle or the measure of the arc. However, you may recognize, I hope, that you see this vertical, or not vertical, that linear pair inside. Linear pairs are supplementary. They add up to 180 degrees. So we would do 180 minus 28, which is 152 degrees. So that's what we're going to be using for our arc. Over 360 for the whole circle. We don't know the arc length, but we can figure out the circumference of the whole circle. The radius is 12. Okay. Cross multiply, so 152 times 24, 3648 pi equals 360x. And then divide by 360. So 10.1 pi equals x. This is the answer in terms of pi. If you would like a more specific answer, you would do that times pi, which would make this 31.8 centimeters long. All right, I'm going to show you this sector area one, and then you're going to do the last two on your own. If you feel like you can already do it, then go right ahead. All right, so in order to find the sector area, we need the degree of the piece. So that's 90 degrees. It's a quarter of our circle over the whole circle. We don't know the area right now, so that's going to be x. And we need to know the area of the whole circle in order to finish our formula. The radius is 6, so 36 pi. Cross multiply, 90 times 36 is 3240 pi equals 360x. Divide by 360. So 9 pi equals x. And in context, we can multiply that by pi. So this area of the circle is 28.3 centimeters squared. All right, I want you to do these two. So pause the video right now, do these two problems, and then come back and check. Please pause now.